Hi, I'm Dr. Leonie. Chapter 11, Analysis of Variance one-way ANOVA. We want to refresh. Remember the factory producing the phone G. We have three cases. The first case is when the factory only producing the model phone G1. The factory claims that the phone G1 can last for 200 hours always, all the time. But we disagree with that. So we take 5 samples and then we do a statistic test. What formula can we use? We want to use the one independent sample t-test formula. Then we can check whether it is same as 200 hours lifespan or it is different. So after the conclusion, we found that the t is equals to negative 0.467. It falls under the do not reject area. At the end, we come out with the conclusion saying that do not reject the null hypothesis. Do not reject the null hypothesis. The second case, the factory is producing the phone model G1 and phone model G2. We don't know whether the lifespan of G1 and G2 same or not. Is it 200 hours G1, 200 hours G2? We're not sure, but we can use a statistic test to confirm it. So we construct our null hypothesis first. We'll say that, okay, phone G1, the lifespan same as the phone G2 lifespans. Then we construct our alternate hypothesis says that, oh, phone G1 lifespan different compared to the phone G2 lifespans. What formula can we use? We can use the two independent sample t-test to do the comparison. This is the formula here. Then at the end, after we plug in the mean from phone G1, mean from phone G2, the standard deviation phone G1, standard deviation phone G2, the n, and also the n. So we're going to get our t equals to negative 0.1975. When we locate t, it falls under the do not reject area. Means that we are not rejecting the null hypothesis. Means that more likely the lifespan of phone G1 is same as the lifespan of phone G2. Next questions. If the price of the phone G1 is 700 and then the phone G2 is 800, which one do you want to buy? So since the lifespans will be the same, so we're going to buy the phone G1 because it's more cheaper. We'll look at the third case. The third case, when we have 3 or more models of the phones. For our case, we do a simple scenario. We only have 3 models, the phone G1, the phone G2, and also the phone G3. We want to check whether the lifespan same or not. So we construct the null hypothesis. We'll say that, oh, their lifespan will be the same for phone G1, G2, and G3. But we can have another hypothesis expectation saying that, oh, they might have different lifespans. What formula can we use? We can use the one-way analysis of the variance, that is the one-way ANOVA, to test it. So the formula seems like simple. We're going to get the F ratio equals to the MSB divided by MSW here. But in order to find the MSB and MSW, we need to construct the ANOVA one-way ANOVA table first. So it takes some time to construct this table. So for this problem, at the end, our F ratio equals to 1.2, and it falls under the do not reject area. Means that we are not rejecting the same lifespan between those 3 models. Coincidentally, these 3 problems come with the conclusion do not reject. So what happened when we have the case ANOVA, one-way ANOVA, we are reject the null hypothesis. After we are rejecting the null hypothesis, we need to proceed with a post-hoc test. For our problem, we want to use a popular post-hoc test. It's called the Turkey honestly significant difference. This is the third problem that we discussed. We have phone model G1, G2, and G3. The conclusion is do not reject. So we do not proceed the post-hoc test. Let's look at the new case. The factory producing the phone G1, phone X4, and phone X5. When we do the one-way ANOVA test, the conclusion would be reject the null hypothesis. When we reject the null hypothesis, we will come out with the conclusion saying that at least two means will be different, but we are not sure which two means. Maybe it's between the G1 versus the X4. Maybe it's between the X4 versus the X5. We're not sure, but we're going to ask the post-hoc test to help us. In order to construct the post-hoc test, we're going to follow the same 6-bit step too. So the first step is to construct the null and alternate hypothesis, and then which formula that we want to use for the post-hoc test. And then the third one is what is the Q value. It's quite similar to the case we extract a value from the table. Then when should we so-called reject and do not reject? That means that which pair has a significant difference, which pair do not have significant difference. So what is our result there? And then what will be our conclusion? This one we'll discuss during our class later on. But at this moment, what you need to do is to come out with your rejection value here. How can you come up with the rejection value here? So you are constructing the one-way ANOVA table. This is what you want to do today and tomorrow and submit it in eCampus. In order to find what is the F ratio here, we need to find what is the MSB, mean square between, and mean square within the groups. In order to find the MSB, we need to have the value of SSB and SSW. So where can we get the SSB and SSW? It's from the table here. Where can we get the value from here? It depends on the value from collection from here later on. So construct this table and then find what is your F value and then solve the problem for the G1, X4, and X5 and then submit into the eCampus. Okay, bye.